This is Learning Assessment Problem 10.9. The problem-solving strategy here is working with circuits containing ideal transformers. Before we begin the solution, let's make some notes on the circuit here. We have the primary side of the transformer with the voltage V1 appearing across the transformer winding, and then the secondary side with the voltage V2 appearing across that winding. The turns ratio is N is equal to 2 to 1 or 2, and we're asked to determine a current I1 in this circuit. And the approach we'll use is transforming the impedance on the secondary side of the transformer to the primary side using the relationship that an impedance on the primary side Z1 is equal to an impedance on the secondary side Z2 divided by N squared. In this case, that will be equal to Z2 divided by 4. We'll indicate the impedance on the secondary side is Z2, and the impedance reflected to the primary side, we'll call that Z1 then. So we'll begin our solution here. Z2 on the secondary side of the transformer circuit is 2 minus J2 plus 2 ohms, which is equal to 4 minus J2 ohms. Then reflecting that impedance Z2 to the primary side, we'll have that Z1 is equal to Z2 divided by 4, which is equal to 4 minus J2 divided by 4, which is equal to 1 minus J, 0.5 ohms. Now we can do a Kirchhoff's voltage law summation around the loop current I1, or the voltage source 12 at an angle of 0 degrees volts is equal to the sum of the voltage drops around the impedances, and that it would be I1 times the 2 ohm resistance, the minus J2 ohm capacitive impedance, and then the impedance reflected back into the transformer primary, Z1. And this expression, substituting Z1 that we have already into there, will obtain 2 minus J2 plus 1 minus J 0.5 times the current I1, or solving for I1 we'll have in polar form 12 at an angle of 0 degrees volts divided by 3.905 at an angle of minus 39.81 degrees ohms. And finally we could solve for the current I1 as 3.07 at an angle of 39.81 degrees amperes.